Hey there. Today we're going to learn how to add and subtract mixed numbers with uncommon denominators. So here I have an example of 4 2/3 plus 3 3/4. And the first thing I want to do is I want to rewrite my problem so that my numbers are stacked on top of each other. And the only reason I choose to do it that way is because I'm going to be adding my fractions and my whole numbers separately. And this allows me to just draw a line down the middle to keep those numbers separate. So I'm just going to focus on my fractions to start with. And as I'm looking at my fractions, I notice that I have different denominators. In order to add or subtract fractions, I need to make sure that I have a common denominator. So I'm going to pull my fractions out and see if I can find a common denominator between 3 and 4. What I'm really looking for is a common multiple between 3 and 4, and I know that 3 times 4 is 12, and there are no less multiples than 12 that 3 and 4 have in common. So I'm going to rewrite my denominators, or my fractions, with 12 as my denominator. Now, here I've changed my denominators in both cases, and if you change your denominator, you have to change your numerator in the exact same way. So I asked myself, what did I do to 4 to get to 12? Well, I multiplied it by 3. So if I multiply my denominator by 3, I also need to multiply my numerator by 3. 3 times 3 is 9. And then I come over here and I say, what did I do to 3 to get to 12? Well, I multiplied it by 4. So once again, I also need to multiply my numerator by 4 to get 8. And now I've created what's known as equivalent fractions. So 9/12 and 3/4 are equivalent, and 8/12 and 2/3 are equivalent, but they have the same denominator, so I can add them. And I'm only going to add my numerators. 8 plus 9 is 17, and my denominator stays the same. Now here I have what's known as an improper fraction, or a fraction that's greater than 1, and I don't want to leave it where my numerator is larger than my denominator. So I'm going to turn it into what's known as another mixed number. And I do that by dividing. 12 goes into 17 one time with 5 left over. So my new fraction, or my new mixed number, is 1 5/12. I'm going to take this answer and bring it over here, but I'm not going to do it all together. I'm going to take my whole number and include it with my whole numbers on this side, and I'm going to take my fraction and leave it on the fraction side. And now all I need to do is simply add my whole numbers together. I have 1 plus 4 is 5, plus 3 is 8. So my final answer is 8 5/12. Let's look at another example. This time we'll do subtraction. Let's do 8 2/5 minus 2 1/4. Then again, I'm going to set it up so that my numbers are stacked on top of each other. I'm going to separate my fractions from my whole numbers. And I'm going to pull my fractions off to the side. I have 2/5 minus 1/4. Again, if I think about my multiples of 5 and my multiples of 4, the least common multiple that they both share is actually 5 times 4, which is 20. So I'm going to rewrite my fractions using 20 as the denominator. I'm subtracting. And I'm asking myself again, how did I change my denominator? Because I have to change my numerator in the same way. So from 4 to 20, I multiplied by 5. So I need to also multiply my numerator by 5. And that gives me 5. And from 5 to 20, I multiplied by 4. So I'm going to multiply my numerator over here by 4, and that leaves me 8. So now I have, again, common denominators that I can subtract. My denominators stay the same, and all I'm really subtracting is my numerator, which is 8 minus 5, which is 3. 3/20 is already in simplest form. I do not need to reduce it any further. So I'm going to bring that fraction over here. And now all that's left to do is subtract my whole numbers. 8 minus 2 is 6. And my final answer is 6 3/20.